Large language models are fully capable of generating production-grade web architecture, yet many developers consistently extract disjointed, generic code. Treating the AI as a conversational chatbot rather than a rigorous software compiler is the primary cause of this failure. Conversational prompting produces marketing cliches and isolated files that require heavy manual integration. Consistent results require a shift in perspective. The AI must be approached as a mathematically constrained tool. This starts with XML constraint engineering, defining the model's logic boundaries before it generates a single character. The next layer is brand persistence, where rules are packaged into callable skills to eliminate the friction of repetitive prompting. Finally, development must move to terminal-native execution, allowing an AI agent to govern entire code repositories rather than isolated snippets. To ship high-converting web architecture, developers must abandon the chat UI and adopt systems engineering. Predictable output is the result of prompt architecture, not conversational requests. Large language models suffer from instruction bleed when given free-form text. Without clear delimiters, the model struggles to distinguish between context, examples, and rules. This 4-block XML prompt pattern establishes those boundaries. It utilizes native training on structured data to create a rigid logical pipeline. The instructions block assigns the precise role and deliverable, like a conversion copywriter producing a single-page HTML file. The context block establishes the brand identity, audience data, and any source material the model must reference. The task block defines the exact programmatic job required, focusing on the specific conversion goal. The output format block locks down the dependencies. It specifies mobile breakpoints, CSS methodologies, and accessibility requirements. Within the context block, the developer can enforce negative constraints by embedding a banned phrases list. This outlawry targets the empty adjectives that signal AI generation. Terms like game changer, unlock, and elevate are explicitly forbidden. The most effective constraint in this block is a direct command. If the model would normally write a generic phrase, it must instead substitute a concrete claim or skip the section. This forces the AI to search its context for specific data points, like a water usage metric or a GOT certification, rather than defaulting to hollow superlatives. By prioritizing explicit constraints over probabilistic guessing, XML boundary structures force the model to prioritize data retrieval over generic hallucination. Repasting these XML blocks into every session is inefficient. The solution is to package brand identities and prompt constraints into a permanent, callable skill file. This skill file utilizes a 2-part architecture. The top contains the YAML front matter, a lightweight metadata block including a description of under 200 characters. The bottom contains the markdown body, housing the actual XML constraints and brand voice rules. This architecture enables progressive disclosure, a method for managing massive amounts of context. At the start of a session, the model only scans the 200-character YAML metadata. The heavy instruction block is only loaded into the active context if your prompt semantically matches the description. This selective loading allows for libraries of brand templates and conversion frameworks that run without bloating context windows or increasing token costs. Custom skills transform repetitive prompting into a permanent, callable logic library. Single-file, browser-based outputs are incompatible with production environments that rely on multi-file structures. Professional development requires moving to a terminal-native agent like Claude Code. This allows the AI to operate directly on the repository, constructing interconnected files autonomously. This autonomous work is governed by a root-level control file that acts as the technological governor for the entire project. This file enforces global standards. It dictates the technology stack, the CSS methodologies, and the exact typography to be used across every file the agent touches. It ensures that brand palettes and forbidden coding patterns remain consistent throughout the directory tree. Moving to a terminal environment provides access to a 1 million token context window. This massive buffer allows the agent to ingest and comprehend an entire web framework or Shopify theme at once. The agent analyzes the existing files to learn the established visual and code system. By understanding the entire ecosystem, the agent can generate new, multi-file pages that integrate perfectly with the existing codebase. Development speed is further increased through custom/commands. These commands allow the developer to instantly scaffold entire directories, following rigid, predefined templates without leaving the command line. CLI orchestration and root-level control files turn AI from a snippet generator into a tool for shipping deployable web architectures. The production pipeline is now established: XML constraints for logic, skills for memory, and terminal orchestration for execution. However, using the most parameterized model for every simple task is financially inefficient. This logic flowchart shows the concept of multi-model orchestration, matching the specific pipeline step to the most cost-effective model. The heaviest, most expensive model is reserved for the initial structural logic and complex creative direction. A mid-tier model is used as the default workhorse for coding the pages and drafting copy. The fastest, lowest-cost model is dedicated to high-volume mechanical tasks like variant generation and metadata tagging. This routing methodology optimizes compute costs while maintaining the quality of the final architecture. The final step is execution, deploying the successfully compiled web architecture out to a live, global production environment. High-level AI development is a matter of systems engineering, not a conversational experience. Treating the AI as a terminal native compiler is the definitive line between amateur prompting and professional engineering.